Good evening, everyone, and it's almost the end of this last week of August. And earlier this week, it was very hot. It was very muggy, and I knew it was part of it, but we had severe weather. Wasn't able to get a scientific video out to you about this, but now it's starting to make the rounds, and everyone is asking, corn sweat. It's corn.
It's corn.
And sweat. But it's not only corn. So yes, we're talking about corn sweat. It is the process called evapotranspiration. Evapotranspiration is the process in which water from Earth is evaporated or transpired. So in corn and soybeans, that is the case. Stay with me on this. It sounds ridiculous, but it is true. So corn, mature corn, so later in the summer, releases a bunch of water, up to 4,000 gallons of water per an acre of corn. So imagine a field of corn, just 1 acre of that can release up to 4,000 gallons of water a day into the air. Okay? Soybeans can also do this. So if you have soybeans and corn late summer and we get a heat wave and all of a sudden the dew points are way up and it feels ridiculously hot, well, in the corn belt states, it's corn. And that phrase is called corn sweat. So no, it's not like us. They're not, getting rid of water to stay cooler in the same fashion we do, but they are releasing that water to kind of adjust their temperature. So yes, go back to Monday. In Iowa, where there's a lot of cornfields, they had dew points in the lower to middle 80s because of this. So their air temperatures were in the middle to upper 90s, and with the dew points in the lower to middle 80s, it was feeling like 110 to 120 degrees because of the corn.
Because corn is awesome!
So the corn and soybeans can actually change a local and almost regional climate when it comes to a very hot dome later in the summer. So yes, corn sweat is a real thing, and if you were to take all the corn in Illinois and have them release about 4,000 gallons of water a day per acre, they could fill 72,000 Olympic-sized pools per day. Crazy to think how much water that corn and soybeans release when they're at the mature stage. Pretty crazy, huh? So that's why I'm standing in front of NAMBOP today, because even here, even smaller localized farms do feel warmer with corn and soybeans. And that's why a good chunk of the lower peninsula, Illinois, Wisconsin, Iowa, southern Minnesota were baking at the beginning of the week because of the corn and soybean fields releasing more moisture in the air, which in return made it feel extremely hot. And our air temperatures were in the 80s and 90s, but when you factor in how much moisture is in the air, that made it feel even warmer. So there you go, corn sweat. It's wild to think that I'm making a video on corn sweat, but there you go. Have a good evening, everybody. And welcome everyone to a science video for you today. Today is actually kind of more of an experiment that you can do to show refraction. Now, if you recall back a few videos, we talked about refraction and essentially how it produces halos and sundogs. Well, we're going to change that up a little bit and show you more of the refraction side and exactly what you can do to kind of prove or show anybody how refraction works, and also what people use to combat kind of a little bit of refraction. So first off, all you're going to need is a glass, see-through glass, and also a number 2 pencil. Super simple. You can use a pen, you could use a smaller glass, but make sure you can see through it because that's kind of the whole concept. So fill it up with a little bit of water. I just filled it up with half. And then take your number 2 pencil and drop it in the glass. Now, you may say, well, how is that showing refraction? Well, simple. When you get down here, it's actually pretty crazy. It looks like the pencil actually goes back and then down. It looks like a Z. The glass and the pencil don't meet up right where the water is. And that's refraction. So what's happening is you have light coming through the glass in the water, and the water is actually bending the light, hence why the pencil looks like it's in two different locations. And then when you look above it, well, yeah, it's in one spot. But when you look through it, that is where you have refraction. So this is a typical case. So let's say, you're out doing whatever and you see a fish in the water, right? Well, when you're looking down, well, it's probably close to where it's at, but there's an angle to it because of the light coming through. Now, when you're looking down at it horizontally, you're kind of taking the majority of that refraction away. But when you're looking at it through the plane, that's where the refraction is taking place. So that is why when you're looking through something, it looks broken. And that's because the light is bending. I have these glasses. Now they are polarized, but polarized glasses help a little bit of this. Now, polarized glasses are usually fishermen will use them, or anybody who wants to see a little bit clearer. I use them for really driving and golfing because it takes away the glare as well as kind of flare. So what happens is these glasses come with a super coat of chemical on them that doesn't allow all spectrums of light to come through them. So it protects your eyes from UV light. But at the same time, it only allows those certain ones from the top. So it takes away the flare and the glare with certain spectrums hitting it from the front. So if you were using these as a fisherman, you would actually be able to see a little bit better into the water where fish might be. Now, when you're talking about refraction here, one thing if you're in a boat and you see a fish down the water, it's not at that exact point. Because of the light, it's refracting, so the angle to it is going to be a little bit different. And if you have polarized sunglasses or specialized sunglasses, you'll make that out a little bit better. So there you go, refraction. Cool little experiment for you to try and also explain. Pretty crazy to think that waves are going through that water and then bending what goes this way, but it looks completely broken. Pretty cool, huh? A little science for you. Have a wonderful day, everybody.
Rapid
Here's a line of storms that is currently working its way across
Fife Lake and Benson. One of the last ones to Lake County arrive.
So let's
Doesn't
go
look like
quick what we have. Lake Ann, you are just now starting to see the first portions of this storm. And it is continuing to move east at about 45 to 50 miles per hour. In Grand Traverse as well as Benzie County, seeing that purple, you're seeing some cores of hail there for areas into Benzie, Grand Traverse County. Areas in Wexford, not a ton of hail, but up towards Mesick, they might be seeing a little bit of hail at the moment. Now, northeast corner right here in Lake County, starting to see possibly some larger hail. And again, that's the cell that has me a little intrigued because it looks like it's taking a lot of energy from the Baldwin section of the storm, and then also a core of hail there in northern Newaygo County. So what is looking to be the norm here with these storms? Rather than name them all and give you updates here, let's talk about what we have going on right now. We have a line of storms that are stretching from Traverse City all the way down towards Newaygo. Now, this is working its way from west to east at 45 miles per hour to 50 miles per hour, but feeding off of that very warm, very muggy air that we have just sitting in northern Michigan at the moment. And with these storms from Traverse City down to Newaygo, there's three things that we are seeing that is very gusty, damaging winds, heavy torrential rains, and also some hail. Not sizable hail, but just a little bit of hail. Not just the main, there you go. Took out half of our birch tree in our front yard here, just in front of Nambob. So yeah, that is the reason we had 2 power bumps. Thankfully, the stream didn't end and actually continued on. It's the leading edge here, which this is typical with a line of storms. When you get a line of storms, such as this one, kind of starting to anchor itself off, you tend to see a little bit of rotation just off to the east. The green is going towards the radar, which is back up in Gaylord. The red is going away. So when you have the green and red that close, that is signifying to us rotation. So the winds there, oh, there it is, tornado warning, nailed it. Tornado warning there for Midland County, northern Midland County, as well as Bay County. But it looks like currently Midland County towards Bombay, Hurley, Schaefer, Baker Roads, these areas look to be seeing that rotation right here. This is our concern, and this is what you always hate to see when you look at velocity, is the greens and reds sharing space.